Hi everyone. So today we are going to do some proofs involving similar triangles. So remember we learned yesterday, well not yesterday, Monday? We learned a couple days ago, whenever that was, that there are some similarity shortcuts when proving that triangles are similar. So we have angle similarity, two congruent angles in each one. We have side angle side similarity, one pair of congruent angles and two pairs of proportional sides, and then we have side similarity. Now when we do proofs with similar triangles, I would say 95% of them are going to use angle just because like in a proof we haven't really learned anything about like how you would write in a proof that sides are proportional. There are some cases where you're given that sides are proportional, and then you would just have to show that a pair of angles are congruent. There's actually one of those in here, but typically you're, for the most part, going to use angle. So if we look at this first one, I'm just going to do, this is the practice that you guys are supposed to do. I'm just going to do a few of them for you, and then you can do the rest. So here's number one. So we're given that GK is parallel to HJ. And so that's given. So we have some parallel lines here. Remember when we have parallel lines, I always say to look for either alternate interior angles or corresponding angles. So we actually don't have any alternate interior in this picture. Remember alternate interior on different sides of the transversal. So with these two parallel lines, this would be one transversal and this would be another. So alternate interior would be like that one and that one. So a lot of times with stuff like this, like kids force it and just like say there's alternate interior even though there's not. So there are corresponding angles though. You could do like this one congruent to this one, that's corresponding. This one is congruent to this one, that's corresponding. You could also do reflexive property. Angle I is congruent to angle I. That would work too. You only need two pairs of angles though. So I'm going to do a corresponding and I'm going to do reflexive just so you have an example of reflexive being used. So I'm going to do, two. I'm going to do, let's see, angle G. I can say G with one letter because it's the only one there, is congruent to angle, this one, I can't say H because there's too many angles there with H as the vertex. So I have to say IHJ. And then that's because of the corresponding angles postulate. Okay, I could also, if I wanted to, list this one and this one in that same step just to save some space, but just so I can show you how you would use reflexive in a proof, I'm going to not do both pairs of corresponding. So I guess I could erase these, not that it really matters. Next, I'm going to do I congruent to I. So angle I is congruent to angle I, and that's reflexive. So you can do reflexive with angles just like you can with shared sides. So that's reflexive property of equality. Okay, so I now have angle. What we're being asked to prove here, I probably should have looked at that. We're just asked to prove that the two triangles are similar. So we've accomplished that. So now I'm going to list triangle GIK is similar to triangle HIJ. And all you have to write here is just angle, and with a little similarity symbol like that. So that's the first one, pretty straightforward. A lot of them are just as easy as this. There are a couple at the end that are a little harder, but nothing too crazy. So if you take a look at the second one, notice the prove is a little bit different. We're being asked to prove that parts of the triangles, that sides of the triangles are proportional. So by definition of similar triangles, once you determine that triangles are similar, you could then say that any of their corresponding sides are proportional. Just like if you remember when we had congruent triangles, once you proved that triangles were congruent, you could prove that any of their corresponding sides were congruent. Remember CPCTC? Well, there's a similarity version. It's the same kind of idea, but just stands for different things. So ready? It's CSSTP. Or you could say CP, corresponding parts, but it's really corresponding sides of similar triangles are proportional. So I'm just going to abbreviate that. Corresponding sides of similar triangles are proportional. So see, that's where the CSSTP comes in. Corresponding sides of similar triangles are proportional. So in a case like this, you'd have to first show that the triangles are similar using usually angle, like I said, so it's pretty easy. And then you can say that the corresponding sides are proportional by CSSTP. Okay, so that's given. So in this example, we have this is parallel to this. We have this transversal where we could use G and K. We have this transversal where we could use I and H, or we can do vertical angles. Your choice. It doesn't really matter. I guess I'll do both of the alternate interior angles. I don't know. No particular reason why. So let's see. In this case, I can say angle G and angle K, and I can say angle H and angle. Oops, I wrote over this. I can't even figure out what it is. Is it a J? Oops, too far. J. Okay, there we go. I can say G and K. I can say H and J because there's no other angles there with those letters as their vertex. So I can say angle G is congruent to angle K. And then I can say angle H is congruent to angle J, and both of those are in step 2, and it's just the alternate interior angles theorem. Okay, so now that I have established that we have two pairs of congruent angles, now we can say the triangles are similar. So I have triangle GHI is similar to triangle. So I went from one arc to 2 to none. So I'm going to go 1, 2, none. So to KJI, and that would be angle similarity. And now that I've proven that those triangles are similar, I can say this, GI over KI equals HI to JI. And how do I know that? Oops, what am I doing? I'm mislabeling these. Whoops. My dog scraping at the door is distracting me. I don't know if you can hear that in the background. I'm going to let her in a second. But it's corresponding sides of similar triangles are proportional, CSSTP. Okay, so that's number 2. So that's all I'm going to do for the easier ones. I'm now going to flip to one of the more difficult ones. So these are all pretty easy. They're all pretty similar. So just remember, anytime you're proving the triangles are similar, usually it's angle, but not always. Like see in this one, you're given that two pairs of sides are proportional. So you're kind of on your way to side angle side. So let's see, those are the easy ones. Oh no. Okay, and so a little further down, you'll see we have these proofs where number 1, 2 is pretty easy. 1, 3, and 4 are like slightly harder. Probably 1 and 4, maybe the hardest ones. I guess I'm going to do number. I guess I'll do number 1 with you. So let's see what we're given here. We have AB congruent to AC already. Isosceles triangle theorem is popping out to me. Not quite sure if we'll use it, but let's see. Then we're given that PD, where's PD, is perpendicular to AB. So here's AB, here's PD. Think about what that means, right? We'll have some right angles here. And then it says AF is perpendicular to BC. Okay, so we'll have some right angles there. And then we're asked to prove, let's grab another color, that FC over DB is equal to AC over PB. So that last part there, what we're being asked to prove, that shows you which triangles we need to show are similar. We need to show that this triangle here is similar to this triangle here. Now, if you want to redraw them. I'm going to erase a little bit of this so I can see everything better. Whoops. Oh boy, I went a little overboard. Okay, hold on. So let's see. This one is congruent to this one. Okay, so you can kind of see like where we're going with this, right? These two sides are congruent. So let me actually restate all the given information real quick. So we have AB is congruent to AC. PD is perpendicular to AB. AF is perpendicular to BC. Okay. So let's get started. So let's see. Let's first deal with AB being congruent to AC. Like, why do you think they would tell us that? I already said isosceles triangle theorem. Do you see how B and C? That would be helpful because remember, hold on, I'm going to highlight these triangles. These are the triangles we're trying to show are congruent. This one, not congruent, similar. That one and this one. And I know that because I looked at this and I looked at the segments that they're talking about that they want to be proportional, and they were in those two triangles. So you can see that this angle here would match up with that angle here. And they happen to both be in triangle ABC. So this one, what we're going to say next is we're going to say, whoops, that angle ABC is congruent to angle ACB, and that's just isosceles triangle theorem. Notice how things we learn in previous chapters always pop back up. So that's isosceles triangle theorem. Now I already marked that we had right angles. I couldn't go straight to saying angle. Remember that if you're going to use right angles as congruent angles, you need to say that they're congruent. In order to say that they're congruent, we need to say that those right angles exist. In order to say they exist, we're going to use the given information of right here, the perpendicular lines. That's another way to show perpendicular, by the way, with the little box. It's the same thing. So we know they're perpendicular. So now I can state that this is a right angle and this is a right angle. Technically, all four of them are, but you don't really need the one to the left of each one because we're not going to use it in the triangles. So I'm going to say angle PDB is a right angle. And in the same one, I can say angle AFC is a right angle. How do I know they're right angles? Because I know the definition of perpendicular. Okay, so now I can say that those right angles are congruent, which I need to say because I'm going to try to use those in angle. So I can say angle PDB is congruent to angle AFC, which would be, we can just say right angles are congruent. Okay, so now we have two congruent angles. We have these and these. So now we can say the triangles are similar. So triangle PDB is similar to triangle, so PDB would be AFC. And that would be angle similarity. And now that I've shown that, I can say that those corresponding sides are proportional. Technically, this is actually incorrect in this proof here. When you have segments like this in a proportion, they're not supposed to have the bars on top. So these are actually not supposed to be there, but not a huge deal if you include them. So the reason for those sides being proportional is corresponding sides of similar triangles are proportional, CSSTP. So there's one that's a little bit harder. Really, none of the other ones are as tricky as that one. And even that, I think a lot of you probably could have done by yourself without me showing you. But I just figured I'd show you one of the trickier ones. So that is it for what I'm going to do. So you try the rest. Let me know. Come for Act Lab if you need some help. Remember, we have a quiz next week, which includes one proof, probably an easier one, and some word problems. So you have a good week. And again, please come for Act Lab if you think you might need some help with this. All right. Have a great day.